So for today, we have the homogeneous differential equation. We have a sample problem for this topic. So first, we define what is homogeneous differential equation. In simplest term, a differential equation is said to be a homogeneous differential equation if every term has the same degree. So if the term x and y has the same certain exponent, it is a homogeneous differential equation. The homogeneous differential equation can be written as m as a function of x of y dx plus n as a function of x of y dy is equals to 0. The m term here is indicated as the dx and the n term here for dy. So there is a condition when solving homogeneous differential equation. If m is simpler, use x is equals to vy and dx is equals to v dy plus y dx. And if n is simpler, use y is equals to vx and dy is equals to v dx plus x dv. So another example of homogeneous differential equation. So the equation is 3 times 3x squared plus y squared dx minus 2xy dy is equals to 0. As I said, homogeneous differential equation if the same terms has the same degree. So the x term has 2 exponent and the y term has 2 exponent, so it is the same, so it's homogeneous. So in this side, it is the dx as m and the dy as n. So we know which is the simplest. So find out that the n is simplest, so we use the formula of n. Let y is equals to vx and dy is equals to v dx plus x dv. Substitute from the original equation. Copy the 3 and 3x squared plus y squared vx squared v squared and x squared dx minus copy the 2 and x times vx is vx squared and the dy copy the dy v dx plus x dv is equals to 0. The common factor of this is x squared, so 3x squared multiplied with 3 plus v squared dx minus 2v squared v dx plus x dv is equals to 0. So they both have x squared, so we eliminate the x squared. Divide both sides by x squared, cancel out. 3 times 3 is 9 plus v squared dx minus multiply this 2v squared dx minus 2vx dv is equals to 0. And 9 plus v squared dx minus 2v x dv is equals to 0. So this is our variable separable differential equation. So in variable separable differential equation, which is we need to group all terms of x to dx and all terms of v to dv. So divide both sides by x, 9 plus v squared. So cancel out the 9 plus v squared. So dx over x minus cancel the x, 2v dx over 9 plus v squared is equals to 0. So that we will integrate the dx over x and integration of 2v dv over 9 plus v squared is equals to 0. The integration of dx over x is ln of x. So the integration of this 2v dv 9 plus v squared is negative ln of 9 plus v squared, and the integration constant c, which is c, and ln of x is equals to c and transpose the negative ln 9 plus v squared in order to make it positive. So plus ln 9 plus v squared. So they both have ln sign, the x term and the v term. So we need to cancel out the x term. To cancel out the x term, we exponentiate them both. So e raised to ln of x is equals to e exponent of x and e exponent of ln of 9 plus v squared. So cancel out the e and the ln, and this we put this x, and e raised to c is always a constant. a raised to ln of 9 plus v squared. Cancel out the a and the ln. The remaining is 9 plus v squared. It is not our final answer because there is a v in this final answer. We need to we go back to the solution. So, but v is equals to y squared. We will substitute the v into y squared in order to get the final answer. So, x is equals to c 9 plus y squared over x squared, and x is equals to c multiply there this and 9x squared plus y squared over x squared, or we rewrite as x cubed equals c 9x squared plus y squared. This is our final answer. The arbitrary constant is not defined, so it is general solution. Another example of homogeneous differential equation. The equation is y dx is equals to x plus square root of y squared minus x squared dy. As I already said that, it is called homogeneous because it has the same degree of each term. The x term has the exponent of 2 and the y term is exponent of 2, so it is the same degree of 2. So the dx as m and the dy as n. So let's find out which is the simplest. So we know that m is the simplest, so we use the formula of m. Let x is equals to vy and dx is equals to v dy plus x dv. So let's substitute this to original equation. Copy the y and the dx is v dy plus y dx. Is equals to x, which is vx vy plus square root of y squared minus x squared. So x squared, v squared, and y squared dy. So copy the y and the v dy plus y dv is equals to vy plus the common factor of y square root of 1 minus v squared dy. So y v dy plus y dv is equals to y. We have common factor of y, so y v plus square root of 1 minus v squared dy. So divide both sides by y. They have y, so in order to eliminate the y. So cancel out this, copy the v dy plus y dv, and cancel out this copy that is v dy multiply this plus square root of 1 minus v squared dy. So we have common factor. We need to cancel out this, divide them both sides. So cancel this, remain y dv is equals to copy this square root of 1 minus v squared dy. So it is a variable separable differential equation. In variable separable differential equation, we need to group the term y to dy and term v to dv. So divide both sides by y 1 minus v squared raised to 1 half. So cancel out the y and copy the dv over, and it's also the same that 1 minus v squared raised to 1 half to over square root of 1 minus v squared. Cancel out this, remain dy and copy the y. So you need to integrate these two because we grouped them already. Integration of dv over square root of 1 minus v squared is equals to integration of dy over y. So from the table of integration, the integration of dv over square root of 1 minus v squared is equals to arc sine of v. So remove this and we put this arc sine of v here and copy that, and this the integration of dy over y is ln of y and plus the integration of constant c. So this is not our final answer because we need to substitute the b in our first solution, which is v is equals to xy. So r sine of v substitute, so it will be make x over y is equals to ln of y plus the constant. So the arbitrary constant is not defined, so it is general solution. Our first sample problem of homogeneous differential equation is the equation is y squared dx plus x squared plus 3xy plus 4y squared dy is equals to 0. And when x is equals to 2, y is equals to 1. So the homogeneous differential equation said that the equation called homogeneous if the two terms x and y has the same degree. So here the x 2 squared 2 exponent and the y has 2 exponents, so they have the same degree, so that this homogeneous differential equation. So y squared dx, we assume that this term and the m the term of dx, and x squared plus 3xy plus 4y squared dy, it is m in the form of dy. So which is simply the simply is m, and we let that the m in formula that x is equals to vy and dx is equals to v dy plus y dv. So we substitute y squared dx plus, we substitute the x v y squared dx and v dy plus y dv, v plus the x squared and vy, v squared y squared plus the 3xy 3v y squared, put this y squared because there is 1 y there, and plus 4y squared dy is equals to 0. Then they have common factors here. In homogeneous we need to make simpler the equation. So y squared v dy plus y dv, and plus common factor of these two is y squared, so that divide both sides y squared, and the remaining is v squared plus 3v plus 4 dy is equal to 0. Then divide both sides by y squared because they both have y squared in order to eliminate y squared. The remaining is v dy plus y dv plus the v squared dy, the 3v dy, and the 4 dy is equals to 0. And then this is combined like terms v dy and the 3v dy. So copy the y dv plus v squared plus 4v, it is 4v because 3v here and then 1v here, it is 4v plus 4, and then common factor of this 3 is dy, so you put the dy outside equals 0. Then divide, and it is already a general solution. The general solution said that we must group the like terms, the dv to v and then dy to y. So divide both sides by y multiplied by v squared plus 4v plus 4. So cancel out the y, dv over v squared plus 4v plus 4 and plus dy over y is equal to 0. So we rewrite the dv to dv divided by v squared plus 4v plus 4 to dv over v plus 2 squared, then plus dy over y is equal to 0. Then integrate both sides. Integration of dv over v squared plus v plus 2 squared is negative 1 over v plus 2, and the integration of dy over y is equals to ln of y and the constant outside. But the v is equals to x and y. Substitute the letter v to x and y. So copy 1 over v plus 2 x over y plus 2 plus ln of y equals c. So we divide, multiply x divide x over y plus 2. So negative 1 over x plus 2y over y plus ln of y equals c. So, or we rewrite this negative 1, that's reciprocal of this fraction is negative y is equals to x plus 2y plus ln of y is equal to c. So here, the given is when x is equals to 2 and y is equals to 1, we substitute the x to 2 and the y to 1. So here, negative 1 divided by 2 plus 2 and the y is 1 divided plus ln of 1 over y is equals to c. So the constant here is equals to negative 1/4. So this is not our final answer. We put this now basically put the c in here. So negative y over x plus 2y plus ln of y is equals to negative 1/4. So multiply by 4 of x plus 2y is equals to negative 4 plus 4x plus 2y ln of y is equals to negative 1x plus 2. So 4x plus 2y ln of y is equals to 4 minus x minus 2y. So the final answer is 4 multiplied by x plus 2y ln of y is equals to 2y, 4y minus 2y is 2y minus x. So it is the final solution and it is the particular solution because the c constant has already a value. This is another example of homogeneous differential equation. Equation is y 2x squared minus xy plus y squared dx minus x squared by 2x minus y dy is equal to 0. So it is homogeneous also because the x term and the y term has the same degree in the second degree. The y term is second degree and x term is second degree. So the dx term is as n and the dy term as n. And the simplest form of this two is the n, so that we use the n formula. Let y equals to vx and dy is equals to v dx plus x dv. So let's substitute this formula from the equation. Y is equals to vx multiplied by copy the 2x squared minus x minus xy vx squared because there is an x, so that x squared plus y squared v squared x squared. So y squared this, I squared this vx, and dx is equals to minus x squared 2x minus vx, and the dy is v dx plus x dv is equals to 0. So the common factor, we find the common factor of this. In here, this common factor is x squared. So vx times x squared is vx cubed, and the remaining x is 2 minus v plus v squared dx. And the common factor here is x squared also, so that x cubed 2v dx plus x dv is equals to 0. So divide x cubed, so divide both sides by x cubed and multiply the v in each of here. So cancel x cubed, 2v minus v squared plus v cubed dx, and here cancel the x cubed and multiply this, substitute this 2. And 2v minus v squared dx minus 2 minus v xd xdv is equal to 0. So, combine, add the same value. And here, this is the same. So, cancel this. And the remaining is v cube dx plus here. So, rewrite this from x v minus 2 dv is equals to 0. Then it is already a variable separable equation. So in variable separable equation, we need to group each term x and y. So divide both sides by x v cube, so that here cancel out the v cube, remaining is dx over x plus copy the v minus 2 dv over v cube is equals to 0. So we already have grouped them, and we need to integrate both sides. So integration of dx over x plus integration of dv, integration of this you need to separate, but it's also the same. dv over v squared minus 2, the constant, integration of dv over v cube is equal to 0. So the integration of dx over x is ln of x plus the integration of dv over v squared is 1 over v squared, and the integration of negative 2 dv v squared v cube is negative 1v plus the integration of integration constancy is equals to 0. But v is equals to y over x. So this is not our final answer. We need to substitute all the v to y over x. So ln of x is equals to, we substitute the v to x squared over y squared, because we need to reciprocal this, because it is 1 over v squared, so it become x squared over y squared, and the same this minus x minus y, reciprocal also, plus c is equals to 0. And this is our final answer, and it is a general solution because the constant is not defined.